So we saw different means of polarizing the light, right? And we also saw that, see, if the two planes of the crystal, if they are parallel to each other, then there was no change in the polarized light, correct? Whereas if they are 90 degrees, they are perpendicular, then there was no light coming out. Now, why is this happening? Now, what if the two crystals are at some other angle theta? Then what will be the intensity coming out? Because if you actually wear a polarized glass, the light intensity coming to your eye is a little lesser, correct? So how does this particular thing work? Now, what should be the angle so that the intensity will change? Now, for this, we have Malu's law, okay, or law of Malus. So what it tells you, or what it states, is when a completely plane polarized light beam is incident on an analyzer, the intensity of the emergent light varies as the square of the cosine of the angle between the planes of transmission of the analyzer and the polarizer. Okay, so I'll repeat this, then I'll explain what it tells. Okay, so what it states is, when a completely plane polarized light beam is incident on an analyzer, the intensity of the emergent light varies as the square of the cosine of the angle between the planes of transmission of the analyzer and the polarizer. Okay, so so you have the plane of the analyzer and you have the plane of the polarizer, correct? Like this. And we have some angle theta between the plane of polarizer and the plane of analyzer. Okay, so what Malu's law tells you is the intensity is proportional, or it varies as the square of the cosine of the angle, meaning it is proportional to cos square theta. So we got to know so much, right? Okay, so mathematically, if we have to do this, okay, see, what we have is, first thing, the incident light, correct? This is the incident light. Now it splits into two things, that is the component of a cos theta along the plane of analyzer and the component of a sin theta along the direction perpendicular to the plane of analyzer, correct? See, like this, what you are seeing in the figure. So we have a cos theta and a sin theta. Okay, now if we have to look at the intensity, okay, now remember, the intensity of the light is amplitude square, correct? So in this case, it is a cos theta, so we have to square that. So what we get is I is equal to a cos theta whole square, or a square cos square theta, right? Now a square is nothing but the peak intensity, correct? So we'll call it as I naught. So we get I is equal to I naught cos square theta, or I is proportional to cos square theta. This is nothing but Malu's law. Okay, so what we get here is, it's just that which component is going in the particular plane. That's what you're looking at. In this case, we have a cos theta to be going in the particular plane, which is in the plane of the analyzer. Okay, so once you square it, we get I is equal to I naught cos square theta, or I is proportional to cos square theta, right? Now we can figure out what will be the intensity if we change the angle. Okay, like case 1, if suppose theta is 0 or 180 degree, that means if the two planes are parallel or anti-parallel with each other, then cos 0 is 1 or cos 180 is -1. But when you square it, both of them are same, correct? So we just get I is equal to I naught. That's why there is no reduction of intensity of light. Okay, if theta becomes 90, then cos 90 is 0, so there is no light. This is the reason why, if the polarizer and analyzer are perpendicular to each other, there was no light coming out. Okay, now suppose, let's say if theta is 45 degree, then we have I is equal to I naught by 2, correct? Meaning at 45 degree, the intensity of light coming out will be half the intensity of the incident light. Okay, so usually what they do is they keep the angle between the polarizer and the analyzer around 40 to 45 degree. Okay, because around 40% reduction is what usually is recommended. All right, so if you look at the graph, see, this is how it goes. At 0 degree it's maximum, it's 180 also it's maximum. At 90 it is at 0. Okay, so this is how the intensity and theta, this is the x-axis and y-axis part. Okay, so understood what is Malu's law? So Malu's law tells you that the intensity is proportional to square of the cosine of the angle between analyzer and the polarizer. That's how we get I is proportional to cos square theta. Alright, so this is about how polarization of light can be done, and with the help of the angle, how we can reduce the intensity of the light.